Hello guys, we are here to find out the motion of simple harmonic oscillator, or to find out the equation of the simple harmonic motion, or SHM. So let us see. First, here is the body of mass m is attached with a spring whose spring constant is, or proportionality of constant is k, and it is attached to a rigid body. When this mass is displaced from its position of rest to a distance of x from its initial position, then a restoring force F is acted upon the body to restore its initial position of rest. So as we know, the restoring force is equal to the displacement of the body. So there F is equals to minus kx, okay, where k is the proportionality constant. As we know, if we break the F into mass into acceleration, after that we can write it as m into d square x by dt square. It is the derivative of acceleration, is equals to minus kx. Now after that, we know omega is equals to k by m, so we are putting the value of that in the equation. So d square x by dt square x is equals to minus omega square x after equating this. So after that, we shift the omega square x into left hand side. So therefore the equation we get is d square x by dt square plus omega square x is equals to 0. It is the differential equation of SHM. After that, we have to take a trial solution. So let us take x is equals to a into e to the power alpha t. So therefore, after double differentiating on both sides, we get d square x by dt square is equals to a square into x, alpha square into x. Now substituting the value of this d square x by dt square x into the equation 2, or the differential equation of SHM, we get alpha square x plus omega square x is equal to 0. So we take x common from this, and here is alpha square plus omega square is equals to 0. Therefore alpha square is equal to minus omega square, or alpha is equal to plus minus root over minus omega square, or plus minus I root over omega square, or is equals to plus minus omega, where I is equals to root over minus 1. From there, we get the two components of this alpha. First one is alpha 1, which is plus I omega, and second one is alpha 2, which is minus I omega. After this trial solution, we have to get a general solution, which is x is equals to a1 into e alpha 1t plus a2 into e alpha 2t. As we know, alpha 1 is I omega and alpha 2 is minus I omega, so we are just putting the value in that. So a1 into I omega t plus a2 into minus I omega t. As we know, the Euler's relationships is e I theta e to the power I theta is equals to cos theta plus minus I sin theta. So now we just put this relationships in this equation. So we get a1 into cos omega t plus I sin omega t plus a2 into cos omega t minus I sin omega t. After that, we take common from this. We take cos omega t common from both of the terms. So we get cos omega t in bracket a1 plus a2, and here is I sin omega t, and here is a1 minus a2. Here the minus sign is because here the I sin omega t is in the minus signs. That's why a2 here a2 is in the minus form. Now let us take a1 plus a2 is equals to a sin theta, and a1 minus a2 is a cos theta. Therefore, this equation will become x is equals to cos omega t, putting the value of a1 plus a2 in here, so it is a sin theta, and plus I sin omega t. Now again putting the value of a minus a2 here, so it is I sin omega t a cos theta. Therefore, x is equals to a cos omega t. We are taking out the a in the front, so a cos omega t sin theta plus I a sin omega t cos theta. Okay. After that, we know that sin a plus b is equals to sin a cos b plus cos a sin b. We are just putting this putting this equation in that formula. So here we get x is equals to a sin omega t plus theta, where omega t is a and theta is b. Now here x is the displacement, this displacement, and a is the amplitude. The amplitude a is the amplitude of that of that SHM, and omega t plus theta is the phase. It is the phase. So it is the equation of motion of SHM. So thank you guys for watching the video. Thank you very much.